Welcome back to the classroom. My name is Mr. Wong. Today we'll be going through the 2002 HSC physics paper. This is worth 25 marks. Not 25 marks. This is question 25 worth 6 marks. It is to answer module 6, inquiry question number 1, which is about charged particles moving in electric fields and magnetic fields. So we have a pair of parallel metal plates placed in a vacuum and are separated by a distance of 5.00 10 to the minus 3. So that's about 5 millimeters. And it has a potential difference of 1000 volts applied to it. Calculate the magnitude of the electric field strength between the plates. So that's E equals to voltage or potential difference over distance of separation. So we have 1000 divided by 5 times 10 to the power of negative 3. So if we put that into a calculator, let's have a look at what we get. So it gives you about 200,000 voltmeters. Well, at least that's our electric field strength there. It says calculate the magnitude of the electrostatic force acting on an electron between the plates. So the equation we're going to use is F equals to the charge of the particle times the electric field strength. Since we're dealing with the charge of an electron, have a look at your data sheet, what the charge of an electron is, and also we are only calculating the magnitude, so we don't need to consider the fact that the electron is a negative charge. Okay, let's put that into our calculator and see what we get from that substitution. So we get value of 3.204 10 to the power minus 14. It's a force, so it's in newtons. Okay, next one. We have a beam of electrons fired with a velocity of that speed there. Between the plates as shown, a magnetic field is applied between the plates sufficient to cancel out the force on the electron due to the electric field. And it says calculate the magnitude, direction of the magnetic field required by the plates to stop the reflection of the beam. Well, if we look at what we have here, we have our electric field, so positive. That's our negative end. So the electric field goes from here, or from the top to bottom, and which means that our electron, if we just draw a direction for our electron, the force of the electric field is going up. So we want to generate a magnetic field or magnetic force that is pushing down. This is where you need to use your right hand palm rule or your left hand palm rule, so to speak. So using the right hand palm rule, if you recall, the direction of your fingers is the direction of the magnetic field. So that's what we're going to try and work out. The direction of your thumb is for the positive charge. So in this case, since an electron is negative, our right thumb, so my right thumb, so to speak, is pointing in this direction. Okay, because that's the direction in which the positive charge would go. Electron is negative, it's going the opposite direction. My palm should be, or the face of my palm, or the perpendicular face of my palm, if you imagine it coming out to you, that's the force. So if the force I want to generate is going down the page, you should sort of see your fingers pointing like this. Imagine that these fingers are pointing into the page, and your palm is pointing down like so. A bit hard to picture in a 2D image, but we can predict that the magnetic field is pointing into the page like so. That way we can cancel out the force of the electric field. Okay, next part is to calculate the magnitude of the magnetic field that generates this particular force. So we can equate that the electric field strength is equal to our magnetic, or not electric field strength, force from the electric field is equal to the force of the magnetic field. So we know the equation already. Q times E equals QVB. Now these two Q's represent the charge of an electron, so you can cancel them out because you're going to substitute them over. We're going to make B the subject of the equation, so it's going to be B equals to electric field strength divided by the velocity of the electron. We already know what the electric field strength is. It's 20,000 or 200,000 voltmeters. Divide that by the velocity of the electron, and let's have a look at what the overall magnetic field strength will be from that then. Okay, so if we write it out, it's 0.06666 repeater. So if we round it off to 3 sig figs, 0.0667 Teslas, which is the units for magnetic field strength. And it is, since it's asking for direction, although we drew it up there, let's just make sure we write it very clear. B field going into the page. And that's how you do the question. Let me just scroll back out, maybe so you can see the whole response. Well, can't fit it, but we'll just leave it at that then. Alright, if you found this video useful in explaining through how charged particles behave in electric fields and magnetic fields, please give it a like, and please subscribe if you haven't done so already. I'll see you in another video where we go through other concepts in physics, or when we go through other exam papers. Take care.